All right, can you tell if it's quadratic or not? That's kind of going to be the focus of this first part here. Pretty simple. We're going to list some stuff, and I'm just going to start with it, and I'll give you the short version, A through E. Is A a quadratic or not? And the answer to that is yes, and the why is this is standard form. It's the standard form of a quadratic, which is y equals ax squared plus bx plus c. All right, so that's standard form. There's number one. Number two, is this quadratic? You might look at this and think, well, what form is it? If x squared is a quadratic, and many equations have many different forms, so it's hard to tell sometimes when we look at the equation. But the answer to this one here is no. This is a linear function, and y, it takes on the form of y equals mx plus b. Okay, so that's why that's linear, and that's horrible. I need to clean that up, make that an A, make that a better looking A and an R. It's linear. The next one, if you look at this, you notice this is linear, mx plus b, just like the previous one. If you look at x plus 1, that is linear. What are we doing with those two linear functions? We are multiplying these two linear functions together. So the answer for this is yes, it is a product of linear functions. Anytime you multiply, it's the second time today. Anytime you multiply two linear functions together, the product is a quadratic fraction. In fact, if we take something like this and multiply it, we end up with a trinomial. This next one, if you look at the next one, and I ask you what form it is, everybody says it's recursive because of this right here. Yes, you're absolutely right. It is recursive. And this f of n plus n minus, or equals f of n minus 1 is always standard in a recursive. It's this part here which is always like, hey, that's the determining factor whether something's linear, quadratic, or exponential. If it's linear, it's plus a number. If it's exponential, it's times a number. If it's plus mx plus b, then it's quadratic. So the answer to this is yes, right? And it's recursive. So there's recursive quadratic. Now the last one, is it quadratic? And some of you are going to look at this and say, yes, it is. It's quadratic. It has an x squared. Well, the x squared, it's only quadratic if it has a highest power of 2. If it has anything higher than that, it's not quadratic, which this has a power of 3. So the answer to this is no. And it just simply has an exponent of 3. So that's why. So there's that. Now we move on to the, move back up. And the other part of this was you're supposed to look at and identify the differences. So I'm going to start with the middle one here because it's kind of one of the more difficult ones. Now what do we do to 4 to get to 0? What we do to 4 to get to 0 is we subtract 4. What do we do to 0 to get to negative 2? We minus 2. What do we do to minus 2 to get to minus 2? Nothing. Minus 2 to 0, we plus 2. 0 to 4, we plus 4. 4 to 10, we plus 6. So obviously, there is not a first difference. Hands down. So I know it's not linear. It's either going to be quadratic or neither. Well, what do I do to negative 4 to get to negative 2? I add 2. What do I do to negative 2 to get to 0? I plus 2. What do I do to 0 to get to 2? Plus 2, plus 2, plus 2. Second difference, quadratic. So now I'm going to move back up here. The pattern, they're either arithmetic or geometric. And you remember the difference. Arithmetic is plus. Okay, so it's arithmetic. The recursive equation, everybody always gets that. It always starts off with the first term, f of 1. But in this case, what is f of 1? Most people would go back and say f of 1 is 4 because it's the first term in the table. No. F of 1. Where is 1? 1 is right here. So f of 1 is 0. Then we finish the rest of the recursive. F of x is equal to f of x minus 1. And then you have to think, well, gee, it's quadratic, so it's got to be that mx plus b thing over here. So where does the m come from? The m comes from my second difference up here, so that's easy. That's 2x. So plus 2x, because it's plus 2 plus 2 plus 2. And then what about the b part? Well, the b is, what did I do to get back to the y-intercept? Go on page 5 in your book and look at it. Under recursive quadratic, it will tell you, what do I do to get back to b? Well, I have to figure out what b is the y-intercept. I figure out what I have to do to get back to it. The y-intercept is where x is 0. So I'm just going to identify the y-intercept as 0 and negative 2. What did I do to get back to negative 2? I did nothing. I did absolutely nothing. And you would not see this in your work. So it's simply f of x minus 1 plus 2. That's it. All right, so you'll finish in the rest of those. Ask questions if you need to, and study for your quiz. Your quiz tomorrow, if you're going to see this today, is page 26, 27, and 32. And what you have to remember is it's not 32 in your workbook. It's page 32 that was handed out on Friday. So it's this page 32 right here. All right. So I'll pause for a second so you can see that. Good luck.